in some cases, we're going to need a system of equations in order to solve a problem in trigonometry. So we have a couple examples here to kind of show you how that works. The only way you're really going to understand this is by looking at an example problem and seeing a situation where you would need a system of equations. All right, so, and again, just remember from Algebra 1, a system of equations is when you have two separate equations and then you make a substitution one into the other one. So here's an example problem where you might need a system of equations. Sally and Jonathan are on either side of the tree and 40 feet apart. Sally sees the top of the tree at 42 degrees and Jill sees the top of the steeple at 36 degrees. How high is the tree? So a nice little picture for you here. But you could see how the height of the tree could be drawn. We could draw that straight down here. And when you do that, it creates two right triangles. So you have a right triangle here and a right triangle here. So I'm just going to redraw real quick. Okay, here's that picture redrawn, and if I just go straight down, that's the height of the tree. See that? It creates two right triangles. It's an altitude essentially. All right, now why is a system of equation needed? Well, there's simply not enough information without using a system, because they only gave us the total 40 feet here. They did not tell us this, and they did not tell us this. All we know is that the total across the bottom, in between Jill and Sally and Jonathan, Sally and Jonathan, and then it says Jill. That's a mistake. It's supposed to say John, not Jill. Okay, Jill sees the top at 36. Sally sees it at 42, and John, not Jill, John sees the top of the steeple at 36. Okay, anyways, that doesn't matter. But we have 42 here and we have 36 here. So we got angles there. We know the total, but we don't know each piece. We don't know this piece and we don't know this piece. And that's what's going to create needing a system. So what we do down here, and it says the first step is to break up the 40. So you're going to break it up into two groups. And here's the most common mistake. A lot of students say, oh, it's 20 and 20. Well, it doesn't have to be 20 and 20. In fact, it almost looks like, if you go straight down, that this piece here is shorter than this piece here, and it is because of the smaller angle. So that's going to, you have a smaller angle here, it's going to create a longer side here. So we can't say it's 20 and 20. So how do we do it? Well, we know that they add up to 40. So we're going to call one of the distances x and call the other one 40 minus x. Okay, so x and 40 minus x. Now we can set up a system of equations. We'll call this height h and call this height h. Okay, so again, we have h, we have x, and we have h, and we have 40 minus x, two triangles. So we're going to write two equations. We're going to write tan, it's tangent, opposite over adjacent, tan 42. That's for this, I'm doing this triangle right here. Tan 42 equals opposite h over adjacent x. So there's one equation. Now I'm going to go over here for this triangle here, and I'm going to do tangent again. Tan 36 equals opposite h over adjacent 40 minus x. So almost the same equation, except one of them's x and one of them's 40 minus x. Two different triangles. But it's the same h. The height of the tree is the height of the tree. It's a shared side. Think about, remember we did earlier in the year, we did shared sides of triangles. The triangles are sharing that side. That tree height is shared between both triangles. So this h and this h are the same exact h. So if we solve for h by cross multiplying, we're going to do that. So this one's going to be h equals, I'm going to do it down here, h equals tan 42 times x. This one is going to be h equals tan 36 times 40 minus x. Okay, so it's tan 36 times 40 minus x. But notice how this is h, and this is also h. Those are both h. So I can substitute, since they're both equal to h, they're essentially equal to each other. So those two boxed things, this thing here and this expression here, I can now set those equal to each other, and that's what we're going to do to solve this equation. So we're going to say tan 42x equals tan 36 times 40 minus x. Now I need to distribute tan 36 to both of these, distributive property. This is tan 42. Actually, you know what I'm going to do? I'm going to I'm going to do it this way, just so I don't mess around here. Now this is going to be 40 times the tangent of 36, 40 tan 36, minus tan 36 times x. Again, distributive property. Now I'm going to get all my x's to the same side, so I'm going to add tan 36x to both sides. Now remember, tan 36 and tan 42, they're just numbers. You can get those from your calculator. So this tan 42x plus tan 36x comes out to be 1.6. And then this comes out to be 29.06. This is just calculator here. And then I divide by 1.6. And I get 17.83. I did this ahead of time for you. So x equals 17.83. Now, if x is 17.83, okay, I'm going to change colors. I want to find h. Well, I'm going to go back to here, or you could go back to here if you want to. You can go back to either one of them. But this is easier because it doesn't have the binomial. Now I say tan 42 equals h over x. Now we know x is 17.83. So now I can put that in there and cross multiply. See that? So h equals, I just multiplied tan 42 times 17.83, cross multiply there, and that gives me, I did it ahead of time, 16.05. All right, so it's going to be about 16 feet would be our, I'm just going to put it down here, approximately 16 feet would be the height of the tree. Approximately 16 feet would be the height of the tree, not a very tall tree. All right, so that is that, and we'll practice these in class tomorrow.